Hi friends, welcome to Romejo's platform. So this is lecture number 2. So in this lecture I shall be discussing about topic 2, right, from NCERT class 11. So in the last lecture I discussed about what is physics, right, and science, scientific method, physics and unification and reduction I had already discussed in the last lecture. So in this particular lecture I shall cover scope and excitement of physics. So in this particular topic I will have to cover a few topics. I mean, this is the topic and these are the subtopics of this particular topic. Macroscopic, microscopic and mesoscopic, scope of physics, excitement in physics, hypothesis, axioms and models. Whatever subtopics you are noticing in this particular lecture, I mean in my lecture, as I am covering from NCERT, that's why whatever points or topics concept has been written in NCERT, those I have abstracted and discussing in the lecture. So please subscribe my channel. So also link the share to your classmate friend. So in this particular lecture I shall discuss about macroscopic, microscopic and mesoscopic, and these are the topics. Okay, let's get started with this first topic, that is macroscopic, microscopic and mesoscopic. Okay, so first of all, you can notice this diagram. These are the diagram which are present here. You can notice all this. What is macroscopic phenomena? Macroscopic in the sense which is large in scale are the phenomena which takes place at a laboratory, terrestrial and astronomical level. Terrestrial means on or related to the earth or earthly. So macroscopic means we can see with naked eye, right? So large system, for example, this is the system, this is sun, this is earth rotating around it, right? So we can notice it with naked eye. So these are the large object which is called macroscopic object. Included in classical physics, this macroscopic is also called classical physics. Classical in the sense it is old physics, right? Like, and in classical physics, in the classical physics, uh, we can include mechanics. Mechanics is nothing but a study of motion. Electrodynamics we can include study of electric and magnetic phenomena. Optics we can include study of phenomena related to light. And thermodynamics study of heat, temperature, entropy, etc. It means that macroscopic phenomena are those phenomena which are large in scale, and classical physics is included in the macroscopic phenomena. Classical physics is also called Newtonian physics. This is the diagram which is related to this macroscopic phenomena, which is called classical physics, and mechanics, electrodynamics, optics and thermodynamics all are associated with macroscopic phenomena, right? In a microscopic phenomena, this is small in size, which we cannot see with naked eye, are the phenomena which takes place at molecular and atomic level. This is the situation. This is the nucleus and all the electrons are revolving around it. So this is called microscopic, which we cannot see with naked eye. And in case of a macroscopic, classical physics is there, but in case of a microscopic, include quantum mechanics, right? The quantum mechanics is the branch of science which deals with motion and interaction of subatomic particles in atomic level or molecular level. In this situation, these are the fact. Quantum mechanics help us to understand how the universe operates at the atomic level. What does it mean? It means that matter we know about it. If you will go inside of that matter, what will you will get? The unit you will get, that is nothing but cell. It is nothing but atom, right? If you cut more and more, then you will get the smallest element of that particular matter. It is nothing but atom. After that, we can cut it, but at higher secondary level, in 12th level or 11th level, we are calling it, after atom we cannot divide it. Yes, if you go atom inside, first of all matter, after that go inside that, you will get atom. After that go again inside it, you will get nucleus. So therefore atom and nucleus, I mean in atomic and molecular level, the quantum mechanics helps us, right? Several important concepts like quantization of charge we will read in 12th class, chapter number 1. Wave particle duality we will read in 12th class, right? In chapter wave optics. Uncertainty principles are covered in quantum mechanics. It means that there are few topics which I have already mentioned here: quantization of charge, wave particle duality and uncertainty principle. These are the points, I mean these are the topics which are covered in quantum mechanics. So in Simply we can say macroscopic, it means that large in scale, and microscopic is small in scale. And another thing, two approaches, two approaches in physics. One is macro, it is large scale, another is micro, is small scale. But nowadays one new approaches is there. You will get, yes, two approaches are there which has been written in your NCERT book. But if you go page number 3rd, NCERT page number 3rd, bottom of the page, you will get there another new branches is that is nothing but mesoscopic. Mesoscopic in the sense which is in between macro and micro, neither large nor small. So mesoscopic, it means that is the this is the branch which is between microscopic and mesoscopic, and it deals with some tens or hundreds of atoms or in the system. It means that large scale, there are so many atoms and molecules. It means that you can see the diagram, this diagram. This is macro, large. This is micro, small, atomic level. And this is meso. What does it mean? A few atoms, that is 10 or 100 atoms is present here. Therefore, macro, micro and meso. Macro means large, micro means small, and meso means in between macro and micro. These are the approaches in physics. Next, look here, the scale which you can look here, this is the particular diagram which can clear your concept about the scope and scale of physics. Look here, from starting from this point to last point, this universe, this is small in size, very small. This is the size 10 to the power minus 35 to 10 to the power 24 and more that, right? So almost each and everything which is covered in physics, and from here to here, this is nothing but microscopic and this is nothing but macroscopic. So everything, this complete scale which is covered in physics. Yes, definitely there are three approaches, but if you start from initial to final, each and everything covering physics approaches, macro, micro and meso. So these are the reality in physics. Next, look here, why physics is called so exciting. Why? Physics is exciting in many ways. To some people, the excitement comes from elegance and universality of its basic theories. Universality in the sense, universally it is accepted from micro to macro. From the fact that a few concepts and laws can explain, basic concepts and laws can explain phenomena covering a large range of magnitude of physical quantities. What does it mean? It means that one law, one theory can explain from micro level to macro level. Each and everything can be explained by one theory or a few theory. So that is the interesting and exciting in physics. And to some of the others view, which you can see here, the challenges in carrying out imaginative new experiment to unlock the secrets of nature. This is very important. Why physics is very exciting? Secrets of nature. How can we find out the secrets of nature? By doing experiment. That is why physics is very exciting. To verify or refute theories is thrilling. Applied physics is equally demanding. Yes, application and exploitations of physical laws to make useful devices. Yes, there are so many devices we can find out with the help of technology. Yes, we will study one topic, science, physics technology. Wait for a moment. Is the most interesting and exciting part of, and requires a great ingenuity in persistence of effort. In this particular slide, what you can say, physics is very exciting. Why? It is because with the help of a few theories or topic or concept, we can find out useful devices. What we can do, we can find out the secrets of nature. That is why physics is very interesting. Hence, physics is exciting, right? Next, look here, one another topic which is in the topic number 2, that is subtopic, hypothesis, axioms and models. What does it mean? One should not think that everything can be proved. One should not think, very carefully you will have to read this, should not think everything can be proved with physics and mathematics. It means that we cannot prove each and everything in the universe, in the earth or in the world, right? We cannot prove. What does it mean? It means that all physics and also mathematics is based on assumptions, right? All physics and also mathematics is based on assumptions. Yes, each of which is variously called a hypothesis or axioms or postulate, etc. Assumptions in the sense, for example, in this particular class, 11th class, we will have to study Bernoulli's theorem, and so many theorems are there. So many principles are there. We'll have to assume a few points. After that, we can prove it. So these are the assumptions which we will have to consider in physics as well as mathematics, and those assumptions are called hypotheses, axioms, or postulates. However, a hypothesis is a supposition without assuming that it's true. It may or may not true, depending on that. The assuming we are assuming something, that is for supposition, that is called hypothesis. It would not be fair to ask anybody to prove the universal law of gravitation. Are you getting my point? What I'm telling you, it would not be fair to ask anybody to prove the universal law of gravitation. We cannot prove universal law of gravitation. Why? It is because it cannot be proved. It can be verified and substantially by experiment and observation. We can what we can do, we cannot prove it. Yes, we can verify it, whether it is happening or not. We can do experiment. If a large mass, another mass is, the force will experience more and more, right? So this is nothing but experimental and observation. We can verify it, but we cannot prove it. Prove in the sense we have to do mathematically and expression it, right? It is impossible to do each and every cases. Those are called hypothesis to assumption. And what is axioms? An axiom is a self-evident truth. Self-evident truth, while a model is a theory proposed to explain observed phenomena. So therefore, I have already covered what is hypothesis, what is axioms, and what is a model. So axioms is a self-evident truth. It is itself truth, right? And model is a theory which proposed to explain. For example, Bohr model will explain in 12th class. So these are the facts which is associated with this particular subject. So I have already made the clear concept of hypothesis, axioms, and models. So this is all about this. So in this particular lecture, I have already covered scope, excitement of physics. So therefore, I have already made the concept of this particular topic. So thank you. So in the next lecture onward, I shall cover physics, technology, and society in the lecture number 3rd. Okay, so thank you. Bye bye. We will meet in the next class. Bye bye.